Hello, my name is Hans-Peter Arp, and I am the Deputy Coordinator of the Research Project 0PM, and I am thrilled to be talking with Wolfgang Deinlein, who is a leading authority on issues related to European water quality. Particularly, we're going to be talking about how Europe's surface water and groundwater have been severely impacted by PFAS and PMT substances and ways to tackle this impact. So Wolfgang Deinlein is the Managing Director of the IAWR, which in English means the International Association of Waterworks in the Rhine Basin. He is also plays a key central role in coordinating and disseminating for the European River Memorandum Coalition, the ERM Coalition, which we'll be talking about more today. So first, Wolfgang, hello and welcome. Thanks for finding the time for this interview.
Well, thanks a lot, Hans-Peter, for inviting me. I'm glad to be here. Looking forward to the question.
Fantastic. Now I'd like to start the interview with learning more about what you work with at the AWBR and the European River Memorandum Coalition, so our listeners can get a sense of the expanse of Europe's water you are working with.
Okay, of course. The IAWR is the International Association of Waterworks in the Rhine Basin, so it's about drinking water suppliers, an association international between Switzerland and the Netherlands. And there is 61 million people living in this river basin of the Rhine. And IAWR, by the way, is also a member in the potential extended potential user group. And IAWR is not the only association of drinking water suppliers. In other river basins in Europe, there are others, like in the Danube, in the Elbe river basin, also in the Scheldt and Meuse river basin, and all these together, they form the ERM Coalition, which is a huge territory actually between the North Sea and the Black Sea, and we are called the ERM Coalition, the coalition of the European River Memorandum. That's what it's named after. And this coalition, we are going to talk about more in this. It's about the memorandum, the European River Memorandum. That's kind of the first thing that was put out by the ERM Coalition, and this year it was complemented by a second memorandum, which is the Groundwater Memorandum. So these lay down the common understanding of the drinking water suppliers that are in the ERM Coalition.
Oh, wow, amazing. That's like a large region of Europe and Europe's water that that you're working with. And in this European River Memorandum and also the European Groundwater Memorandum, which I've read, and I'll post links to on the bottom of this YouTube chat. But you made explicit mention of PMT substances, meaning persistent, mobile, and toxic substances that we deal with as a central focus in 0PM, and a big family of these are, of course, PFAS substances. And these are an intrinsic threat, really, to Europe's freshwater and drinking water. So maybe could you talk more about that and why the European River Memorandum and European Groundwater Memorandum presented this issue as so important?
Yes, the PMT substances or the VPVM, so the very persistent and very mobile substances, they pose a considerable threat to European drinking water and the resources, and also to drinking water supply. They are considerably critical substances, so we decided to really make a strong focus on that, for them to be phased out and to be not allowed during the approval and authorization of substances, and not only these substances, but also their degradation products and the transformation products. So that's the idea, and that's why we included that in the memorandums.
Mm-hmm. No, these are all extremely important points, and I think a lot of people would agree with them. And so what were some of the other central points of these memorandums in addition to PMT and PFAS substances?
Okay, thanks. These memorandums, they're meant as guidelines for regulation and for the regulators. And there are regulation gaps, which we say these should be closed. And we already do this closing of gaps in the memorandum. We set target values for micropollutants that have no regulation yet. So that's what is an important message to guide the regulator and tell them what is needed from the perspective of drinking water suppliers. And these target values, for instance, for rivers, they are like the environmental quality standards, like an equivalent, but a lot of substances don't have an environmental quality standard. So we do this in the European River Memorandum, for instance. And the common understanding is that the drinking water resources shall have such a quality that drinking water can be made out of that resources by using natural or nature mimicking purification methods only, not the advanced technology that's coming more and more. And we have a common goal, that is to be future-proof, climate-friendly, safe, of course, and affordable, and it should be drinking water for everyone. That's also a common understanding, and yeah, we have some central points. I can go into these also.
What about the role of, upstream actors, such as, the polluters themselves, and how does the memorandum address with like these issues of dealing with the polluters?
Yeah, well, it's 18 countries, 18 states in the European River Memorandum, so they include Switzerland and Liechtenstein also. But actually, it's a lot of what is written down in the memorandum is just coming from European legislation, primary law, like the Treaty of the Functioning of the European Union. It says that the pollution should be rectified at source, not at the end, which are we at the end of pipe and the waterworks, and also that there should be precaution and prevention of substances before they have caused any trouble. And if they cause any trouble, there should be the polluter who's made responsible to clean up what is being done by these substances that the producer usually has produced and released in the environment. And also the Water Framework Directive is a good equivalent actually to what is written down in the memorandum, because there's a ban on deterioration of water quality, and also, well, zero pollution from the European Green Deal as well. That's also a goal of the memorandum. And well, going beyond that, it's also that we say the regulator has to act. If the polluter doesn't stop polluting, the regulator has to act. It's not the drinking water supplier who can put an end to pollution, because we don't have the authority to do that. We need the regulator to be active and to close the source of pollution and rectify it at the source of pollution. And as well, we say that public drinking water supply shall have priority over other uses by industry or by agriculture, for instance, and also that we should value water much more than we do today. Water is the most precious good. Clean water is the most precious good on this planet. And this is what people better understand before it's too late.
It's really important, I think, that the future regulations do address this link between those who say released or produce the chemical and release them environment and those who clean them up, because right now this has always been fragmented, both in terms of policy and I'd even say river basin management.
Doesn't make sense to say that the only problem is the sink, of pollution and not the source of pollution. And sometimes it's like that. So, and we feel that as drinking water suppliers, that we have a high pressure on us, and we say it cannot be the way to go to only look at the waterworks and that they clean up the mess that others do. Of course, we need clean drinking water, no doubt about that, and safe drinking water, but only looking at the emission side is definitely the wrong way to go.
Absolutely, and maybe also I want to go more into this this part of the aspect of cleaning drinking water. I totally agree that eliminating pollution at the source and prevent pollution, that's always the best way. But I don't think that a lot of people really fully understand the challenges that there are of remediating or treating drinking water for PFAS and PMT substances. These are extremely challenging, and sometimes I also get the impression that somebody, a great engineer, or somebody's very excited, they found an exciting solution, for instance, for PFAS remediation, and the media goes all crazy about it. Oh, this is amazing. Maybe we can solve our PFAS problem. But I mean, that's nice in theory, but maybe tell us about it, what it's like in practice, like these super advanced technologies like reverse osmosis or nanofiltration. How hard and expensive are these to implement in a practical way?
Yes, like you say, it's always first of all, it's a problem of scalability, that you have to be able to use it in a big scale. And well, some can be treated, some of these substances can be treated with activated carbon, but usually it's, like you say, it's nanofiltration, or most of the time it's reverse osmosis, which is needed. Well, we're happy to have that, to clean water and to have clean drinking water with reverse osmosis. It works, but it doesn't work on a EU-wide scale. We have to be very clear on this, that it's not a solution for introducing all over Europe. This doesn't make sense at all, because there are technical limitations and financial limitations that don't allow this to happen. And I can go, like, for the technical limitations, just to give an idea of it. We have extra amount of water that is needed for reverse osmosis, which is 20, sometimes even 25% more. 25% more water, you know, and in times of drought, for instance, this water is just not available, and we cannot do this. On the other hand, this extra amount of water that is needed is turned into wastewater, and this wastewater is, well, it's including these substances. So it's only a shift of pollution, you know, it's not eliminating the pollution, it's just shifting the pollution, and this is not the way to go as well. Also, we have the problem that the reverse osmosis produces a demineralized water, which has to be remineralized afterwards, and this produces a need of very large quantities of the minerals. And there's the next question, if these large quantities are available at all. And the big question, of course, is the energy. It needs a lot of energy, a very, very high amount of energy. And we will need to have a closer look at this, also because we want to get climate neutral, you know, that's the idea of where to go to fight climate change. And the energy consumption is way huge, way bigger than this. It doesn't allow to go into the direction of climate neutrality. It's not important, not possible. And if the energy is not available, like we have some shortages or are afraid of shortages right now, what happens then if there is no purification method? We don't have clean water, you know. We're talking about the essential source of life, also of our own lives. And if you don't have clean water, that's not an option to have a landscape where there is no clean water. Instead, only if there is a very high technical treatment possible, and if that treatment has some shortages or whatever, there is no clean water. That's no way to go.
Mm-hmm. Oh, absolutely, and I really like this point that you mentioned about the energy cost, because I don't think that can be emphasized enough, because recently, as you might know, there has been some push from some members of the European Parliament to delay progress on chemical regulations like REACH, saying that we have to prioritize the energy crisis or energy costs. We have to deal with this first. It's more of an emergency, and in the industry, some industries need time to adapt to these energy shortages, but they're neglecting the fact that pollution costs energy. And one of the best ways to help companies address this energy shortage is not pollute, because this is contributing to the energy crisis. So I think that was not, I think this connection has to be made clear, that pollution issue is an energy issue, and the two problems are linked. So I think that's very important and timely, and especially now. And there's also, in addition, like the financial issue, right? It's like we can say the polluter pays, but that also doesn't, that happens more in theory, I think, than in practice. So, but how much would these technologies cost, and where do you think the money would come from if they had to be implemented?
Exactly. Thanks. I just wanted to point out that like equally like the energy, there's huge financial costs connected with reverse osmosis, and we have like calculated that it would be like a city of 500,000 inhabitants. It would be like a 30 million investment to upscale to reverse osmosis. So when we take this number, or we take the number of €1 per cubic meter, which is to be paid for extra for reverse osmosis, and we look at the number of 38 billion cubic meters per year in the EU, according to EEA, this would be a number of investment of 38 billion euros per year. So this is almost the size of the budget for agriculture, which is said to be the largest budget in the European EU budget. So we can just say this won't work. We don't have the money for that, and who's going to pay that? If we transfer it to the drinking water consumer and he cannot afford to pay, well, what then? We doesn't have any drinking water, or she at all anymore, and we have a human right to water, and we have to fulfill this. That's the idea, the way to go, and we really need to get the curve and shift our policies towards protecting our water cycle and protecting our source of drinking water.
When you were talking about reverse osmosis, I'm also thinking about how culturally it can be important for people to have the minerals in their water that are naturally there, right? Like it's when people say, oh, it's like the mineral water, or some people just have to taste the water when they visit home because they say, oh, it's got the right content of minerals, whatever they may be, because they vary geographically. But I mean, technology that removes that and makes all water potentially synthetic, like in a sense, because it's not the naturally local water. I mean, that too is kind of a thing that we have to give up if we have to clean up all water. And I also think that's a point that people don't talk about enough.
Exactly. We don't want purely synthetic drinking water anymore. We want natural or near natural drinking water, and as you say, it gives us a relation to the place where we live, because usually it's a local drinking water, or a lot of times it's local drinking water that comes out of the tap. Yeah, and the idea of that only natural or nature mimicking processes should be enough to make drinking water out of the drinking water resources. That's also the idea, including this idea that there should be a natural drinking water. And that's definitely also the view of drinking water suppliers, that we want to have, where it is possible, where there are some hotspots of contamination, of course, where there's no possibility to have natural water anymore, and we have to use high technology for providing drinking water.
Yeah. So, I mean, the technology will always be needed as a last resort. So we're not, and there'll always be a role for it. But so, I mean, I don't want to be too hard on the people that are working hard in developing that technology. Some of them are working with us in 0PM, and I know it's so important to deal with Europe's most polluted areas. But we want to keep the areas that are not polluted at the same time. So yeah, very good. And I think also, I mean, there's also a rule for these advanced technologies, not as drinking water treatment, but maybe as like industrial wastewater effluent treatment to maybe if these chemicals are needed at a specific location, that they're not being, say, emitted from industrial area or something like that. So that's more closer to the source.
Exactly, and that definitely makes sense to clean the water before you put it into the environment and the water resources, instead of leaving it up to the water suppliers to clean it up. It's the wrong end where we focus on. And there are some very interesting developments, like in the Netherlands. There's the biggest chemical site called Chemelot in the Netherlands, and well, they focus on zero pollution and want to achieve a circular water use in their production until 2050. And right now they have very, very ambitious goals for also monitoring and regulating every individual substance that is emitted right now. So that's the way to go, to really have a very close look at each substance that is being released into the environment, and then close the source of pollution gradually.
So this is really interesting, and maybe now we will move our discussion over to more to policy, because there's a lot of I think parts of the European Green Deal that are related to the PMT and PFAS issue. The biggest one right now, when we're speaking on December 14th, 2022, is the CLP regulation, because most likely on Monday next week, on December 19th, 2022, they're going to introduce new hazard classes for PMT and VPPM substances. And then we're going to hope to see this from there enter other regulations, such as REACH. But what is your outlook for the future of European policy, water policy, and in relation to these types of water contaminants?
Well, that's really important work that you mentioned there, and congratulations for that, right on this point. Well, the source of pollution that I said, just to make a bigger picture, the source of pollution is not only the wastewater pipe, which is usually nowadays below the water level, so you can't see it. It's also like the spraying device behind a tractor in agriculture. But in the most important case, it's the process of authorization and approval of substances before they enter the market. That is really the biggest source of pollution, and we really have to get a grip on that. And this is really the way to go, what you just mentioned, to introduce these new hazard classes into the CLP regulation, and also, of course, the REACH regulation. That's the big step. But after that, of course, we need more steps, because there are extra regulations on, for instance, pesticides, on biocides, on food, feed, pharmaceuticals, but also on cosmetics, also on detergents, and also on food contact materials. That's really important also. Like food contact materials, well, there is PFAS in the non-stick pans, there is PFAS in the grease-proof paper, and this means it's also included in your pizza boxes, a lot of pizza boxes, not in pizza boxes, but also in sandwich paper, in the cup that you take for your coffee to go, and so many uses in everyday products that people don't know of actually. And it's also included in shampoo, in soap, which is really delicate actually. In soap, you use soap to wash your hands, and then it contaminates or pollutes your hands actually. And but that's not all. That's like sun cream. It's like rainproof clothing. It's so many uses nowadays that really have to get rid of these pollutants. And it's a huge regulatory effort that we are facing and that the EU is facing. There's also this talk about essential use. Here we really have to be strict and get a really strictly narrow definition of essential use, so that not your pizza box is defined as an essential use at the end. This wouldn't make much sense. And when we have a close look, a lot of these uses are just convenience uses, like I just call it now, convenience uses. And yeah, nobody will miss it really if you don't have it. Might be a little while, but after that, people they didn't miss it before they had it, so we don't need it actually. It's not much that people need actually. They need clean air, they need clean water, they need food, and they need something to clothe, and that's the essential. And we need clean water, like I just said. That has to prevail actually over these things.
Mm-hmm. Maybe since we're just talking about polluted water for the past half hour or so, is it still safe to drink tap water?
Yes, of course. The UBA, the German Environment Agency, still says it has excellent quality. And you know, the huge problem is the persistency. If we have substances in the environment that won't biodegrade at all anymore, this has to be tackled soon enough, because if they're just persistent, it will just accumulate and accumulate and accumulate, and it eventually pass every threshold that is set, you know. And not only in water. Personally, I think that air is much more polluted than water, because all the incineration of waste leaves into the air. And my personal health advice would be also to eat organic food, because yeah, that's grown organically, and also drink organic coffee and drink organic tea and drink organic beer and wine. Actually, that's all on the market, if you can afford it. It should be affordable to everyone, and there should be subsidies for everyone so that they can buy organic. And yeah, like I say, the drinking water is still excellent quality, and I want to keep it like that. That's what we are working hard for. And here in my kitchen, yeah, I'm really happy to have local water and also climate neutral water, which is just a clean water, which is just a state of paradise to be when you have a close look. And there's so many parts of the earth which are completely the opposite, you know. It's not many people to have clean water. So we really have to get going and preserve our current state.
Absolutely. No, that's a very important note to end on. Everybody should have climate neutral, natural water in their tap, free of accumulating persistent chemicals. Great note to end on. No, but thanks for this interview, Wolfgang Deinlein. It was a pleasure. I definitely learned a lot, and I hope our viewers did too. And it is extremely motivating for us researchers in the Zero PM project to have your support in our extended potential user group, and as well as many others from the European water sector.
Let me thank you on this occasion for your groundbreaking work. I must say it's very, very important what you do, and well, you deserve the Nobel Prize from our point of view. It's not only you, it's also Sarah Hale and the Zero PM project, and also the UBA, Michael Neumann and Ivo Schliebner, all these people doing such a great job. Thanks so much for this.
Okay, well, you're making me blush here. That was a very, very nice compliment. I'm a bit shocked by it, but thank you so much for those nice words. Thank you very much.
Yeah, 2 words.
Okay, well, thank you so much again, Wolfgang Deinlein. And to those who watch this interview and want to get more information and content like this about PMT and PFAS substances and what we're doing towards zero pollution, please subscribe to our YouTube channel at 0PM H2020 or visit our website at 0pm.eu, where we have many different resources, including a newsletter and ways to follow us on social media. So with that, again, Wolfgang Deinlein, thank you very much. And thank you everyone for watching.
Thank you very much. And there are very excellent videos on the YouTube channel of 0PM. Please be recommended that.
Thank you. Bye-bye.
Bye-bye.
0PM, Zero Pollution of Persistent and Mobile Substances. This project has received funding from the European Union's Horizon 2020 Research and Innovation Programme under Grant Agreement number 101036756.